WAN 2.2 is here, and it's seriously stepping up the AI video generation game. And we're going to show you how to run it completely for free in today's video. We're talking sharper details, smoother motions, and more control over the outputs. In today's video, we're going to cover the 3 different models that WAN has released. We're then going to cover how to install ComfyUI, so we've got a nice, easy interface to use it with. And then we're going to go through and show you how to install WAN 2.2 so that it's completely free to use on your local computer. And we're going to get into some examples, what it looks like, some great prompts, and much, much more. But first, how good is WAN 2.2? Well, as you can see here, denoted by the dark purple lines, this is how it's stacking up with their largest text-to-video model, which is what TV2 stands for, the A14, which is that 14 billion parameter model, so one of the top tiers they have. It's now outperforming lots of the AI models out there. Key to note, this chart doesn't include Google VO3, so definitely keep that in mind. It's claiming to be better in the aesthetics quality. We're doing a dynamic degree, the text rendering, camera control, video fidelity, and object accuracy. They're definitely improved versus the version before, but still not market leading for those two. But how have they achieved this? Well, they've done something called mixture of experts. Now, why is this important? Well, the problem to date is that training these text and image to video generation models, size really is the key. The bigger the model, the better it usually performs. But to get these big models ready to go and shipped out for us to use, they're usually extremely expensive in terms of the computing power needed to train that model to get the output. So what is mixture of experts? Well, instead of having one giant model that's using all of the different parts at the same time, this is going through and creating specific experts inside the model. Now, each expert is working like a mini network that's trained on specific, specialized information to get that best output. So what does that mean? Well, if we come to this next part here, it means we're able to use much less compute to get that training done because the experts really understand that data that's coming through and the output we're trying to achieve. We're also able to train much bigger models or use much larger data sets without needing to increase that compute budget. And this means we can get the same quality as the bigger models, but much quicker and faster with the smaller models. And to bring that to life, WAN 2.2 has ingested 65.6% more images and 83.2% more videos than WAN 2.1. And it's also got those specific experts. So for example, it's been given lots of our static data that's been labeled, so the AI knows what it is, including lighting, composition, contrast, color temperature, and much more, so that when we give it the prompt, it's going to get that much better output, and we'll show you that later on. So what are the 3 models they've released? Well, the first one is the T2V A14B. Now, what this means is T2V is text to video, and then 14B is 14 billion parameters. The next one is I2V, so image to video, A14B. And the last one here is all around text and image to video, but it's a 5 billion parameter model. And that's where all of these are using that mixture of experts to try and get the best outputs. So what can they achieve? Well, as mentioned, we've got the text to video for each of these, apart from the last one at the bottom, which is text and image to video outputs. All of them support 780p and 480p outputs. So out of the 3 new models, which one is best to use? As mentioned, we've got the text to video 14 billion parameter version. This is really good for your cinematic video, but you are going to need a lot of VRAM to get that really quality output. If you're looking to have some consistency around the videos that you're trying to generate, maybe bring characters to life, this is where your image to video is really good, and you've got that 14 billion parameter model, which is going to help you get that consistency, but it is that larger model, so you are going to need a lot of VRAM to process it. The other side is that 5 billion parameter model, and it is really good for being able to run it locally to get some really good quality outputs, but there is something you need to watch out for. And that is that a lot of these models are really optimized for GPU performance, so graphics processing unit, i.e. the video chip in your machine, to be able to get the output that you want. And of course, a lot of that is really optimized with NVIDIA to get the outputs that you want. So if you're on a MacBook, this won't really work for you. And if you've got a lower quality GPU chip in your Windows machine, you're really not going to be able to do this locally to the same quality as maybe you want. If you want to do that, I've got a few suggestions at the end of the video around some alternative ways of running this as you need it. Now, for most of us trying to run this locally on our computers, we're going to use that bottom one, which is that 5 billion parameter consumer model. So that's the one we're going to be going through and showing you how to set up today. But if you've got a really big computing power through GPU as well as RAM for your local accessibility, the bigger models you'll be able to use. Now, when you go through to set this up, you are going to need quite a bit of storage ready to go because we're going to need to install ComfyUI locally, as well as all of the different model inputs, tensor files, and the model itself to run it locally on our computer. So you are going to need around 60 gigabytes to be able to get this to run. So to set this up, the first thing we're going to do is come across to setting up ComfyUI, which is going to be the interface for using these models. I'll include the link below so you can find it nice and easily. You've seen this on many other videos. Check out my other one here, which is all around Stable Diffusion and how we can use that one. So we're going to come up to the top. We're going to press download here. I'm using a Mac, so we'll press download for Mac. Once you've got it downloaded, you'll see a screen that looks like this. You just need to press get started. Now I'm using an M1 Max MacBook Pro from a couple of years ago. So what we're going to use is the Apple Performance shaders on the left-hand side here. If you've got an NVIDIA GPU, this will be replaced on the left-hand side here, or you'll need to go down and turn on CPU mode and run it that way instead. For mine, it's absolutely okay to use it this way. We're going to press next. We're then going to choose a location to store it. So in this use case, I'm just going to put it on my desktop, and then we're going to go through and press next. Now we can migrate any of the previous installations we've done, but we're going to go through and just set this up straight away. We'll turn on the automatic updates, usage metrics if you want to do that as well. I'm going to turn that off. And as we can see here, we've got the Python mirror if we want to use that as well. I'm going to go through and press install now. This will go through, take a little while to do it, but as you can see here, it's now setting up the environment for us to be able to use this in the future. But now it's going to go through and set up the environment for us, install everything that we need so we can use these models in the future. This is the quickest and easiest way to be able to set this up. We'll wait for this to come through and I'll show you exactly what it looks like. So we're now starting up our ComfyUI server so that we'll be able to use this, and we'll just wait for it all to come through. So once you've got it all set up, your screen should look like something like this. Now, as you can see on the left-hand side here, we've got a few different templates we can use. So if we come down to video, we'll see here, we've got the different models available to use straight away. You'll also see that they've got a few different ones. So we've got the text to video, 14 billion parameter. So that highest quality one. The image to video, the first to last frame video. We've got fun if, we've got fun control. So there's a few different ones that have gone through and been pre-trained to get the output. For today, we're going to use the 5 billion parameter model, which is more of that consumer grade for all of us to use. As you can see here, we're going to need to go through and download a couple of different files, which is why I mentioned at the start, you're going to need quite a bit of storage to be able to use this. We're going to press download on all of these, and it will take as long as your network speed allows to get them all installed. So I'll see you after they've installed to go through the next part. Make sure to subscribe to the channel. We've got lots of videos around AI and automation. If you want to take your learning to the next level, make sure to check out our community. We've got lots of content in there that relates to AI image and AI video generation, as well as much more. So there we go. It's now about an hour or so later, and we've got all of the different models installed for this. So now if we come out of here, what we should see in the background is the workflow that we're going to be able to use. So we've got the different loading models. So we've got the tensors in here and the clips, which is really key, as well as the VAE to be able to get the output that we're specifically looking for. Now, as mentioned, you've got both the image to video as well as the text to video, which is in here. So if this is not activated, i.e. there's nothing in the image prompt down the bottom here, is going to base it off text images. Now, if you want to get a really good output, that's where the art of prompt engineering comes into play. Now, when it comes to prompt engineering, you want to make sure that you include some of these elements to get the better output. So we want a really clear subject, who is it, what is it in focus, and what are we trying to generate? Are there any actions associated with it, any environment or context, the description of the camera as well, style and tone of that video that we're going after, any lighting and atmosphere points to note, as well as temporal control. Remember, the WAN 2.2 also got given lots of aesthetic data and it's been labeled, so it should know what the output looks like to be able to reduce it for us. So as we can see here, we can go and enter our prompt in here. First things first, we're going to check what that negative prompt actually says. So I'm going to copy this, come across to Google Translate, and then paste in here. So as we can see here, it's making sure that we've got no overexposure, static images, blurred details, subtitles. Again, we want to make sure it's that best quality possible. So for example, if you want it to be really good human quality, that's where we would go through and mention around making sure there's no deformed hands, they don't look weird on sort of the facial structure, the body structure, anything like that, to get the output that you want. So for the video length and size, this is where we're going to be able to make a few changes so that we can get the output that we want. Now this width and height is going to be the dimensions of your video, and then length is going to be the number of frames divided by the frames per second. So for example, 121 divided by 24 would be around 5 seconds of video that you're going to get output. What we can also see here is the ability to make it a image to video module as well. And you just do Control B and it will load it up for you straight away. What you can do is also come up to here for the K sampler. Now we've got a few more details on exactly what each of these are. So some of the key ones are going to be the steps. These are the number of steps in the denoising process, i.e. the quality of the video is going to improve the more steps that we have in that up to a certain threshold. So think of it this way. If you have 10 steps, it's like having a tent outside. If we then shift to have 50 steps, it's where we've gone, for example, and built the foundations of a building, but it's not got any of the glass on the outside. And then if you went up to say like 100 steps, that's where you've then got all of the glass, all of the foundations, all of the different modules inside, rooms, coffee machines, all of this stuff. And that's going to be how you improve the quality of the outputs. We've also got CFG as well, which is another key one. We touch more on that in the community, and the denoiser process here as well. You can change all of this to be exactly what you want, and to get it to run, all you need to do is add your prompts in there and press run down the bottom. Now, be aware, if you're using a MacBook, this is going to take a very long time to get the outputs because a lot of this has been optimized on NVIDIA GPUs. The other side of this is it's also going to be the amount of RAM available on your computer. So the more RAM you have available, which you're going to need a very decent amount to do, you will be able to get the outputs. That's where, as we mentioned on the templates, there's lots of other image and text to video models. So really play around with it and find what works best for you. You may find, for example, LTX or WAN 2.1 or some of the stable diffusion ones run a bit better for you. So how do we then go through and use the 14 billion parameter one? Exactly the same process. You'll come through and, for example, do text to video. You'll be able to go download all of these different modules. Again, as you can see here, they are some very large files that you'll need to include as well. But once it's all loaded up, as you can see here, we'll be able to go through and get our outputs. So exactly the same process. As we can see here, we've got all of the different models that we're going to be loading up to generate our image, as well as the video size. We're then going to be having lots of control over LoRa, which is absolutely great to really fine tune and get the output that we're looking for later on in that output. We've also got the ability, same again, just to add our prompt in there to really get the output that we want and have that really detailed control over that video that we're trying to generate, as we can see here, to then get the saved output at the end, and we can go through it and use it in the future. The other side down here as well is just using a different version. So this is the text to video, but it doesn't include LoRa. So being able to have a more fine-tuned ability over that style of the output that you're looking to trying to achieve. So as you can see here, exactly the same process if we just load all of this up. And as you can see here, exactly the same process just without LoRa, loading in all of our different models. Again, remember this is the 14 billion parameter. So you're going to need a very powerful GPU to be able to run this model, as well as your VRAM as well. We've got the video size, all of these different elements exactly the same to get the output that you want. So let's jump into a few quick videos to see exactly the outputs that we're able to achieve. So this is an output from the 14 billion parameter model. We gave it an example image input. That's why the quality is really good straight off the bat. But as we can see here, it's starting to struggle a bit at the water at the bottom. So it really depends on if you've got the power to do this. I don't think it is market leading for that water, and we'll show you a little bit later on how it compares to Seedance Pro as well as Halio 2. If we come across to the next one, as we can see here, exactly the same principle. We gave it a starter image and it was able to go off and generate the output for us. What you'll notice is I think it performs much better if you give it that starter image just to try and improve the quality of the human outputs, because I find if you run it on its own, it's not exactly the same and it's a bit worse in the quality. It also seems to struggle a bit with water, which, as you would expect, because that is the hardest part of the video generation. If you come across to this one here, I think it does incredibly well for this cat. It looks really realistic. It's got the eyes that blink. They don't look too oversized for the eyes as well. There's sort of emotion a slight bit out of touch, but I think overall that's an incredibly good one that you can embed into a video model. If we come across to this one here, I think this is good. I think it struggles a bit with the realism as we then start to speed it up. It's also got this weird sort of helicopter thing that seems to come in out of nowhere over the top and almost crash into a building. But again, when we're not paying for this and we're able to run it locally, going to compromise on some of the quality. Now, we've also got the ability to have the fast models run, as well as the 14 billion parameter, depending on how you set it up. So to show you the difference, I'm going to play the fast version now from the 5 billion parameter model. As you can see here, it's only really got that light that turns on. It doesn't look very realistic at all for the output that we're trying to achieve with the image to video output. Now, if we come up again, trying to use that higher 14 billion parameter model, as we can see here, we've now got a much more realistic image to video output. The car gets a little bit funky as it starts to move away. It doesn't look as realistic, but it's a much smoother motion. It looks much more realistic than that fast version. So now we're going to run through 3 examples and we gave them exactly the same prompts, and I've used the first output for every single one so that it's fair and we're not trying to improve it straight off the bat. So we've got this first video here, which is all around a monster coming out of the lake. Again, seems to struggle with the water at the start there, and that monster looks a bit like Godzilla, but not quite. It doesn't look very realistic. I think if you went through and did a bit more fine tuning, trying to get the output, you could probably get something that's about 80% of the way there. Now, we're going to compare that to Halio 2. So as we can see in the background there, it's a really smooth camera pan motion, and that monster looks much more realistic. Almost something like the Harry Potter snake from sort of the second film maybe, and it's able to give a really good atmosphere for this, and you can imagine that it's lurking under the water. It is also much better for that water as well for the different styles, so that's why I'd probably look to use Halio 2 over the output that we got from WAN 2.2. The next one is going to be Seedance Pro, and this is again one of the market leaders like Halio 2. If we play this in the background, I think that water looks the most realistic out of the 3, but I think it didn't quite nail that monster and what we meant by monster. So again, if we were to go through and do some fine tuning on that prompt and the output, we'd be able to get much better output. So who would I recommend this to? Well, if you've got the ability to use an NVIDIA GPU locally, then definitely look to use it and you've got some of the VRAM. If not, and you value maybe getting the output quicker, I'd recommend coming across to platforms like Replicate, because if you come down to their video models, as you can see here, they're all ready to go straight away. Seedance Pro, Helio 2. WAN also has the 14 billion parameter model ready to go, as well as the fast versions if you need to get the output quicker. The reason I'd look for something like this is because with my MacBook, it's purely not powerful enough to run this locally. But if we come a bit further down, it's also very cost efficient. So if we're doing it here and there for a bit of a hobby, it would only be 40 cents per output that we're going to do for 480p, or around $1 per output for that 720p. And again, you only pay for what you use. So if you then wanted to come through and use Seedance Pro instead, you'd be able to do that. And it's going to cost you about the same amount of money, because it will be around 75 cents for that output when the target resolution is 1080p, and you're going to be running it for around 5 seconds. So it really depends on if you value maybe paying a little bit more, getting the output quicker, or you're purely not able to run it locally. Let me know in the comments below if you're interested in me doing a video on how you can use an NVIDIA GPU with using RunPod, so that we can get those outputs using ComfyUI over time, nice and easily, without having to pay for every single output that we use. Make sure to come across to our community to check out more around AI and automation. And I also recommend this video here, which is all around local AI video generation as well. Stay tuned for more around AI automation, and have a great day.